You've seen the video clip.
Yeah.
Do you know why I think this video clip is suspicious?
Um, I mean, I imagine it's not suspicious because that's an object applied to, that's a adverb. That's a thing applied to people being suspicious. I imagine it's
Thanks.
suspect.
Right.
But
Okay. You're such a knob.
I imagine it's suspect because maybe you think, first of all, the acceleration is applied unevenly on the water. And second of all, because the water seems to be accelerating faster than she is, even though she's in the water.
Yeah. So
I thought about it a little. I was like, something that seems very weird, but I haven't thought about it enough to figure out whether it is or not.
yeah. So for anyone watching, there's a link for the video clip that we're discussing. It's like a 53-second video of like a teaser trailer for the film Passengers, where Jennifer Lawrence is swimming in a swimming pool and the gravity on the spaceship she is on turns off for some suspicious reason. Now, neither of us have seen the film. Is that right?
Oh yeah, yeah. No, I haven't. In fact, I've avoided everything. This is the only clip I've seen.
Right. Okay. So there could be like a plethora of reasons.
I
Like
mean, there
so,
could be like some gravity field, couldn't there?
yeah, there could be so many things explaining this which might be elaborated on the film, which we're currently ignorant to. So
Yeah,
we might just be making idiots of ourselves.
but that's
But
not new there.
yeah. Anyway, so you can watch that clip if you're watching. I have several issues with this. And so to start with, when the gravity turns off, there's like a cutaway and it goes to like the outside of the ship, and all the lights on the ship, or like loads of the lights on the ship turn off, and like the rotating section around the outside of the ship stops.
Oh really? I didn't actually see that bit.
Yeah,
Somehow I missed that.
play it again. So, unless there is some kind of sci-fi style gravity field generator, then I would imagine that the rotating part of the ship is the bit which is supposed to, the centripetal force generated from that, if you're in that section of the ship, is supposed to simulate gravity, just like they did in
In like
Interstellar.
obviously the other films. Yeah.
Yeah, yeah, exactly.
Yeah. Okay. Okay.
Right. So, if you now you can't actually tell if she's in that rotating section of the ship. Um, I mean, it shows the outside of it, but it doesn't properly show us like where she is within the ship.
Are you sure? I think looking at it again, it kind of does it not pan out? Oh no, you're right. It doesn't. It seems to imply quite heavily that she might be in one of those arms, but yeah.
Yeah. All right. So if she is in one of those arms, which seems reasonable to me, considering like the whole gravity can be turned on and off situation.
Oh yeah, that's a good point.
Um,
Why would the gravity stop?
well, what do you mean?
Well, as in the it can't just be a loss of power. It'd have to be brakes.
No, because it's the thing's spinning, right?
Yeah.
Right. And assuming there's some amount of friction to that spinning,
Yeah.
then
Okay. Yeah.
if you stop putting power into it, then it's going to come to a halt.
Sure, but we're not going to go straight anti gravity.
No, we're not. I'm assuming that she's in that rotating section. So when it
Yeah.
stops rotating, there's no longer like the fake gravity.
Yeah. But as
However,
in what I'm saying is that it's going to come on slowly. It's not going to be like anti gravity. It's going to be like gravity, less gravity, less gravity, less gravity, less gravity, zero gravity.
yeah, yeah, but also, I mean, like having a large body of water on a spaceship is, in my opinion, just a bad idea, because the water is not just going to decelerate with the rest of the spaceship. It's going to slosh around. Like if you imagine like driving a fire truck, if you go like around a corner quickly, it's going to like slosh around on the inside of the fire truck.
Or is that why they don't? So why they don't carry much water in fire trucks?
No, I thought they did. I thought you had to go on like special training to like learn to
Right.
drive.
Huh. I mean,
Uh,
I just mean they have to go to a hydrant, but I mean, obviously they pump out loads of water, so they need some water from the streets. But that's interesting and makes sense.
yeah, yeah. So you can imagine like driving like a container full of liquid that can like slosh around.
Yeah,
Um,
well, it's like it may be slightly apocryphal, but like one of my friend's father's in the Navy, and he was telling me how little water you need on the second layer of a ship before the
right.
ship will just tip over, basically, because the water will slosh back and it'll be an increasing, be a feedback loop, and it'll just more and more until eventually it'll capsize the ship.
Right. Okay. So right. So bearing that in mind, that is interesting. But if the arm's going to come to a halt, then the water should slosh up out of the swimming pool all in one direction, surely.
I agree.
Yeah, as if you kind of like put the brakes on suddenly in a car, like everyone leans forward, like everything travels in the same direction.
Yeah.
Which is not what happens in the clip.
Unless friction is applied unequally, which I don't seem to see it is, or there's some kind of torsion.
Yeah.
Which again, I don't think there is.
Right. So
that's problem one.
That's problem one that I have with this, and I'm happy to be corrected. Two, even if it is some kind of magical gravity field which is just turned off, then
which I think you make such a good point about the arms being there. I literally didn't see that part. It seems almost certain that that's not the case. That seems like a big leap to be like, we've built these giant rotating arms, but they're not the ones creating the gravity.
Yeah, exactly. Yeah. So, but even if it isn't those arms, if I just have a machine which I can like turn on and off, and when it's on, there's gravity in like a room or something like that, and when there's off, like there's none. If I switch that off, everything in the room doesn't just start going mental and like flying against the ceiling. There's no force holding it on the floor anymore. And if I pushed it, it would move. But it's not just going to start rocketing around the room. Some force has to be applied to it to make it do that.
Yeah.
And
there are kind of no natural expansion forces within water that kind of it's going to try and expand upwards a bit.
A little bit. I mean, water, like the amount that water is compressed by the force of gravity, I can't imagine is that amount, is like huge amount in like a swimming pool that's like a couple of meters deep or something.
Yeah.
There's a bit of vapor pressure from the water trying to evaporate, but that's pretty minimal as well. And as long as the spaceship isn't accelerating, then then it's in an inertial state, and everything should just be like, it should stay still. And like as she splashes around in the water, like bits of water would go places, but there's no like obvious energy being put into the swimming pool to make it start like flying around the room like it does.
Yeah, I mean, like a slight caveat, I think water behaves very strangely and is a real nightmare in zero grav. You know, that's what you hear from astronauts, that fluids are a real problem.
Yeah.
But as far as I understand fluid mechanics, there's nothing to explain that.
Yeah.
Not understand them very well.
Okay. So that they're my top two like physical problems with that. My third problem is the supposed difficulty she has in the clip of trying to swim to the surface of this giant globule of water that she's trapped in, right?
Can I throw another kind of related physical problem to this third one?
Go for it.
Is that the water seems to be moving up faster than she is.
When she like gets lifted out the swimming pool.
And why should that be?
I mean, she can move independently of the blob of water. I mean, you're right in that if like a large body of water is moving in a particular direction around you, you'll probably go with it. Because there's like a lot of friction on you as it slides past you. So she should probably stay within the globule, but there's no need for her to be perfectly centered within it.
No. And she's not going to be raised up by kind of the water attempting to move down in relation to her because she's more buoyant than it is. But the opposite should definitely not happen. There's no reason why, unless she's swimming downwards, the water should rush up past her as it does.
Buoyancy, the idea of buoyancy is an interesting question because there is no such thing as buoyancy, I think, in zero gravity.
Well, indeed.
Right. So there's no longer a force trying to push her to the surface of the water, which I think is what this like problem is supposed to be about.
Yeah, but I suppose the main thing is if she's a little bit below the water, and then this happens, she's going to find it much more difficult than she's used to swim to the surface. That is, I would think that we agree on that.
I wouldn't say much more difficult than you're used to. I mean, imagine swimming just like forwards or swimming down,
Well,
even down.
yeah,
Like,
down was a good example because it can't be more difficult than for her to swim to the same distance downwards in a normal pool.
yeah, yeah, it would be easier than that.
Yeah, that's like an absolute cap on how difficult it could possibly be.
Yeah, and within like a couple of seconds, you can swim to the bottom of most like a 3 meter deep swimming pool or something.
And if anything, the thing that would be bad. So okay, let's finish that discussion and then move on.
Yeah,
I agree. It should be fairly easy. There should be no reason why the water's moving more quicker than she is. And even if for some reason she was moving down, it should be fairly easy for her to move through the water.
yes, yeah, that's what I'm saying. I'm going to start doodling since we have this tool.
Yeah.
Yeah, agreed. So, in it,
I might note down other things I'm going to discuss.
in it, there's a point where if I change this back now, she is like once the first like blob of water goes up, she swims to what is kind of the surface of the bubble that she's in.
Yeah. So can I draw like she's like here and she? Oh yeah, you're doing that.
Yeah, so she's like that.
She's going like this way.
Yeah, exactly. Which is fine, and that's fine. And it seems to take a reasonable amount of effort, but maybe she's
I think too much. I mean, she seems to suddenly be much more deep in the water than she was when she was swimming. But whatever.
Yeah. Or
and then like we get this, don't we?
yeah, you go for it. Yeah. So then for some reason the rest of the water in the pool, which has moved independently to the bit of water that she's in, is like this massive wave which is like crashing towards her. And I understand that she might be panicked, right? So like this crazy stuff is happening. Yeah, so that's the wave, I presume. You're not sending me subtle messages.
No. The wave's like, I hate you, Jennifer Lawrence.
Yes. And it like slams into it. And that would be disorientating, but it would be like getting hit in a wave like in the ocean or something. Like you get spun around and stuff like that. The advantage in this situation is that she doesn't have to work out which way's up, because there's a surface to the bubble in every direction.
Yeah, though it's much deeper in the direction she's now swum away from.
Yeah, but even after she gets spun around, and there's like a split second in the clip before this wave like impacts on her, where she takes a huge, great big breath. She's like, so she sees it's coming. And
right, actually, I missed that as well. I mean, so you sent me this video, and I mean, like fundamentally, I managed just to watch very little of it. Oh, because I thought she was still in the water when that happened.
No, like she reaches the surface, and then the wave collides with her.
Right. Yeah. Okay. Yeah.
And she gets tumbled back into it, and then the clip ends with her kind of. So I'm going to draw a secondary bubble. The clip ends with her being in this new, much bigger bubble.
Yeah.
And she's like in the middle of it.
Yeah.
And this is my last problem, is that she is in the middle of it and swimming, but isn't going anywhere.
Yeah.
Which...
And kind of related problem is that if something put her... Let's just take the black arrow again, our force arrow. If something put her here, then there's nothing to stop that something pushing her all the way through. If any force put her halfway through, I suppose friction could have acted on that force.
Yeah, I mean, it's pretty hard to push things through water.
Yeah, okay.
But
so she's been pushed back, and now she's in the middle. But yeah, you're right. Yeah, why is she going nowhere?
Yeah, because there's nothing about gravity has really nothing to do with the idea of swimming. Like you push water back and you go forward. That's inertia. That's how rockets work, and we know rockets work in space. Maybe
she's not very good at swimming. Maybe that's the issue. She spends a lot of time in this like crazy underwater like anti-grav whatever pool.
Yeah,
anti-grav pool, but she's not that good.
She's just a bad swimmer.
Yeah.
Maybe they explain all of this away in the film by just being like, yeah, I'm not very good at swimming. Maybe since I've got all this time on my hands, I should do a lot of practice.
Yeah, she's not like, the guy in Prometheus who can like unicycle and speak 17 languages. She spends the time.
Swim?
Well, he's an android, so probably this will do him even worse than it does her. Um, that's right, everyone. Pop culture references.
If you can build an android of that complexity, surely you'd bother making it waterproof.
Yeah, I know, but I mean, I, I'm. It's not a very nice android. So they seem to have failed on some slightly more fundamental things. Well, I say fail. I mean, some people aren't very nice. Lots of people aren't very nice. So. If I can just jump in with my earlier issue.
Yeah, please.
I think they've missed a trick because actually the biggest problem here would be confusion.
Agreed. Yeah, yeah. It's like when someone gets swept underwater or is like tied up in like a sudden wave or something, and then all of a sudden you're underwater and you don't know which way's up.
Like if I was going to do this as like as a set piece, like set pieces, then what I would do is I would have her inside the bubble.
Yeah.
And I mean, okay, maybe the bubble's an issue in itself, but we'll cross that bridge when we come to it. So she's inside the bubble and she's like, oh, I'm going to swim upwards. So this is her and she's going upwards. But the bubble's moving up. And then finally she reaches the top of the bubble as the bubble crashes into the ceiling.
Right. And then suddenly she's at the equivalent of being at the bottom of a pool.
Yeah. And then she's like, oh, no, how am I going to get out? And then she's confused. And maybe we have the moment like where she's like, I'm dead. And she's what am I going to do here? And then at that moment, you could have like a nice she couldn't save herself moment, which, I mean, this isn't, I think it's just nice to have the characters where they realize they can't save themselves.
Yeah.
And then the bubble just kind of washes sideways.
Yeah.
As it smooshes off the roof.
Right.
And she manages to cling on to something and suddenly she can breathe.
Yeah. Or she can push off the floor or the ceiling in this case.
Or she can finally finds the ceiling and she can kind of, you can even have a kind of a nice moment where she is left standing
on the ceiling. Yeah.
On the ceiling, kind of like, bedraggled, confused,
because
alive.
Like the water, so that there's like a scaling issue here as well. Whereas I think when you think of water droplets, kind of like rain droplets or something, they're quite sticky in that, they stick to like glass and they stick to each other and stuff like that. But a big bit of water doesn't behave in the same way because the stickiness and the viscosity of water doesn't scale with the amount of water that you have. So a big globule of water doesn't stick to the ceiling, and it's still like it wouldn't adhere in the same way a little droplet does, even in 0G.
Well, so I mean, when I pitched this idea to Warner Brothers, I was like, honey pool. I thought it'd be a bit gross to have Jennifer Lawrence in a honey pool. So
which would be way more dangerous.
I was like, let's have Chris Pine or Pratt, whichever one of he is, or somebody else, somebody different, like some other actor, Jack Black.
Black in a pool of honey.
In a pool of honey, and then it goes wrong. Honey heads to the ceiling.
Yeah. That sounds like a colloquialism. When honey heads to the ceiling.
Yeah.
I don't know what it means, but
yeah.
So that's my issue, is that she's like drowning in the middle of this globule of water with no apparent means to like move herself. But she's actually in a much better position than an astronaut could find themselves if they were like suspended in the middle of a room of air, because then they actually have almost nothing to push off. Like you can swim in air, but because air's so kind of not dense, like thin, then you can't push very much mass, and therefore you can't propel yourself very easily. Whereas in water, like that globule doesn't look like not even as large as like twice her size.
Yeah.
So that's like a couple of breaststrokes to get to the surface.
Yeah. Well, or like 10 or 12 if you're not very good at swimming.
Yeah. And swimming underwater is even more efficient than swimming on the surface.
Yeah, or less efficient if you're not very good at swimming. But I take your point. I'm starting
it's still more efficient. It's just more dangerous if you're bad at swimming.
I know, but like if you have like back, if your legs are going in the wrong direction when your arms are going,
you're like turtling, so your arms go up and your legs go like down.
Yeah, it's a turtle disaster.
So these are all my issues with this trailer.
So should we just do a quick recap of the issues?
Yes. Absolutely. Please, from your perspective.
So I think we had four issues. Those issues roughly are number one issue was we don't really understand how this is being done in the first place because anything that seems reasonable is going to be a gradual process and all the water's going to move at once. Issue number two is that it wouldn't be that hard for her to swim in any direction, let alone the fact that it wouldn't be that difficult just because she's in anti-gravity.
Yeah.
It would be more difficult than to swim downwards.
Yeah.
The third thing is that when she's in her own bubble, she somehow seems to miraculously swimming nowhere, something I think is probably impossible. And I think the fourth one, I was kind of like, and the fourth physical problem is that she, the water properties are kind of incorrect. It has this kind of large globular thing, which wouldn't necessarily be the case.
Yeah.
And my kind of issue was they didn't really discuss how confused she might be, which would have been a nice golden bullet. Silver bullet.
Which would kind of like explain everything. As like if she's confused and she's not acting in her best interests because she doesn't.
She kind of clearly seems to be, and physics is against her.
Yeah. The fifth thing that I've just come up with now is that a good way to explain why she might be confused is that there could be a whole heap of air mixed into these bubbles. There's no reason why in 0G. In fact, I've seen examples of actual astronauts on the ISS, and they blow bubbles inside water, and they just kind of bounce around the inside of the bubble of, like a bubble of air inside a bubble of water. So there could be loads of water mixed into the globule she's in, which would offer an interesting like dynamic for her to get like gulps of air potentially. But if there's lots of little bubbles within that bubble, which it could be since it's like smashing around the ceiling and stuff like that.
So you could be breathing in water.
So if there's loads of little air bubbles, then suddenly you can't see through the water so easily, and therefore you don't know which direction to swim in.
Yeah.
But then you also can't see Jennifer Lawrence from the outside of the bubble, which poses a problem for like cinematography.
But in my version, you can't see Jack Black, and that's probably a good thing.
Honey is transparent.
I know, but I'm just saying, if there's all the bubbles in the honey, we can't see Jack Black.
Yeah, agreed.
That's fine. We're not losing anything there.
It's way harder to put bubbles in honey than it is in water.
Really?
Well, if you think about like the energy it takes to like stir honey and to like whisk bubbles into it, I would imagine.
Sure. Yeah, okay, I'd say that. I don't know if anyone's ever going to watch this, but if they are, I feel like we might want to like cut it off now that we've done like a full segment.
Yeah, agreed. If you disagree strongly, fiercely with our, or maybe you've even seen the film, unlike us, then please feel free to post your counter argument, which we will readily fight back against, since I'm sure we know best in our current position.
We can be pretty vitriolic.
Yeah, exactly.
No honeyed words from us.
And that's the end.